So we're still on Newton's second law, but we're going to look at some practical situation and use mathematical principles to evaluate these scenarios. So the first question. So again, Newton's second law, which states that the net force applied to an object is equal to the mass of the object times the acceleration of the object. But remember, the original form of the law states that the change in momentum with respect to time, and we use the that fact to derive that the force is equal to mass times acceleration. So the original description of Newton's second law is that the applied force or the net force is equal to the change in momentum with respect to time. And then we analyze that and derive that the net force is equal to mass times acceleration. So we're going to use that principle in solving our problems today. So the first question is: an applied force of 50 newtons is used to accelerate an object to the right across a frictional surface. Again, remember that moving to the right, the velocity is positive, acceleration is positive. So the object encounters a 10 Newton of friction. So it's moving to the right, it encounters a frictional force 10 Newtons. So the frictional force is going to be in the opposite direction, so it's going to be to the left. Use the diagram to determine the normal force, the net force, the mass, and the acceleration of the object. So that's the question. So let's analyze what's going on. The first thing you have to do, if you get a question like this in your exam, you have to draw the free body diagram. You cannot solve this problem unless you draw the forces acting on the object. So, of course, let's look at the forces acting on the object. Okay. So the force of gravity is going to pull the object downwards, and the normal force is going to be of the same magnitude but in the opposite direction. So what we know is that an applied force is an applied force is acting on this object, and it's accelerating to the right. And the frictional force, so we draw the forces that we know. All right. So frictional force, the applied force, force of gravity, and the normal force. So the force of gravity and normal force balance out each other. So these two forces balance out each other. So these are balanced forces. So the object is not going to go up and it's not going to go down, because the downward force balances the upward force. The applied force is to the right, the frictional force is to the left. So the net force, so you can subtract the frictional force from the applied force, and your net force is equal to 40 newtons, okay? So 40 newtons, okay? Um, if the force of gravity, so look in the diagram, the force of gravity downwards is 80 newtons. So we know the normal force is going to be the same thing. So the normal force is going to equal to 80 newtons, but upwards. So we know the normal force. It's the same thing as the force of gravity, but it's in the opposite direction. The net force, we know it's 40 newtons and it's to the right. And then they want us to determine the mass and the acceleration. So because you know the normal force or the force of gravity. Remember, the force of gravity is equal to the mass of the object times the acceleration due to gravity. Okay, so let's write that out. So the force of gravity is equal to the mass of the object. Okay, that's a big M, but don't worry about it. Times the acceleration due to gravity, and we indicate that by a little g. All right. All right. So we know that the force of gravity is 80. We know that g is a constant number. Okay. So g is 9.8 meters per second squared. So the mass is equal to the force of gravity, which is 80, divided by acceleration due to gravity, which is 9.8. Okay, okay, so this is 9.8. Just bear with. So that's 9.8. If we, so we can assume that G is 10, but the accurate number is 9.8. If G was 10, then the mass would be 8 kilograms. This pen is not working for me today. So that's 8 kilograms. So we determine the normal force, we determine the net force, we look at the mass, and then it says, what is the acceleration of the object? Again, force, net force that is equal to the mass of the object times acceleration. Okay, so the object is moving to the right, so the acceleration, sorry, the net force is to the right, so the acceleration is going to be to the right as well. So acceleration is equal to force divided by mass. Okay, so the net force acting on the object is 40. We determine that by subtracting the frictional force from the applied force. So that's 40 divided by the mass, which is 8 kilograms. So that's equal to 5. Okay, and that is 5 meters per second squared. That's acceleration. Okay, so you first have to draw your free body diagram, and then you use your knowledge of the direction of the forces, the information that they give you, and then you try to solve what's going on. You have to get the net force, because net force is what causes acceleration. Okay? And when you give this acceleration, you have to say what direction. Remember, the acceleration is going to be in the same direction as the net force. Okay? All right. So I think that wasn't too bad. All right. So let's look at another problem. All right. So this is another problem. Okay. So the question reads, an applied force of 20 newtons is used to accelerate an object to the right across a frictional surface. The object encounters 10 newtons of friction. Use the diagram to determine the normal force, the net force, the coefficient of friction between the object and the surface, the mass and acceleration of the object. Neglect air resistance. So the first thing you have to do is get your free body diagram. Okay? So the applied force to the right is 20. The frictional force gonna be to the left in the opposite direction, 10 newtons. The force of gravity is 100 newtons, and then the normal force. Remember, if the object is pushing down on the surface with 100 newtons, the surface is going to push back up on the object. Same amount of force, but in the opposite direction. So the normal force is equal to 100 newtons. Okay? So your normal force is equal to 100 newtons. The net force, okay? So you have 20 newtons of force applied to the right and a frictional force of 10. So your net force is the difference. So the difference between 20 and 10 is 10 newtons of force, and this is to the right. So let's write that in. So it's 10 newtons of force, and force is a vector quantity. So you have to indicate the direction. So it's 10 newtons of force to the right. Okay, all right. So then the next question, the normal force, we already determined that, the net force, and then the coefficient of friction between the object and the surface. We know that the frictional force, if you remember, frictional force, the frictional force is equal to the coefficient of friction, the coefficient of friction times the normal force. So you have to always remember these things. So the frictional force is equal to the coefficient of friction times the normal force. All right, it's a big N, don't worry about it. It means the same thing. So the coefficient of friction then is equal to the frictional force divided by the normal force. So we know the frictional force is 10 newtons and the normal force is 100, because it's the same thing as the force due to gravity. Okay, this is a zero. It's just a zero in a different language. But anyway, this is a zero. So 10 divided by 100 is equal to 0.1. So your coefficient of friction is 0.1. Okay? The coefficient of friction is 0.1. So you determine that. Okay, 0.1. So what is the mass of the object? All right, so again, if you use your force due to gravity is equal to, so let's just put a little f right here to denote so you don't mix it up. So this is the force of friction, and then the force of gravity is equal to the mass of the object times the acceleration due to gravity. Okay? So they want you to determine the mass. So the mass is equal to the force of gravity force of gravity divided by the acceleration due to gravity. Okay, so the force is 100, force of gravity is 100, acceleration due to gravity is 9.8 meters per second squared, but for simplicity, let's use 10. So our mass would be 10 kilograms. So that's 100 divided by 10. So that's equal to 10. So the mass of the object is 10, and then you want to determine the acceleration of the object. Again, force, the net force, so you have 20 newtons of force to the right, frictional force to the left, net force is 10, okay? So using net force, small n for net force, is equal to the mass of the object times the acceleration. So to solve for acceleration, you're going to divide the net force by the mass. The net force is 10, so our acceleration is equal to the net force divided by the mass. So net force is 10, mass is 10. Just you have to use your imagination. Net force is 10, the mass is 10, so the acceleration is 1 meter per second square. Acceleration is 1 meter per second square. So you're using your knowledge of Newton's second law to solve these problems. So, all right, so let's look at a third problem. Okay. All right, so let's look at the third problem. So this problem, a 5 kilogram object is sliding to the right and encountering a friction force that slows it down. So the object is sliding to the right. It encounters a friction force that slows it down. Remember, friction is going to slow moving objects down. The coefficient of friction between the object and the surface is 0.1. Determine the force of gravity, the normal force, the force of friction, the net force, and the acceleration. Neglect your resistance. So you're going to slow down a little bit and just look at the object. So a 5 kilogram of object is sliding to the right, okay? And it encounters a friction force that slows it down. All right, so you have to the first thing you have to do is to draw the free body diagram. Okay, the first thing you have to do. So you have an object which it's sliding to the right, but force of friction, which is to the left, is slowing it down. Okay, of course, it's on a level surface, so the force of gravity is straight down and the normal force is straight up. This object is slowing down, so the net force on this object is the friction force, which is slowing it down. The net force on this object is the frictional force, which is slowing it down. Again, we're given the mass, so we can calculate the force of gravity, and as a result, we'll know the normal force. The force of gravity, okay, The force of gravity is equal to the mass of the object times the acceleration due to gravity. So our force of gravity is equal to the mass of 5 kilograms times the acceleration due to gravity, g, which is it's 9.8 meters per second squared, but for simplicity, we'll call it 10. So just imagine this is a 9.8. So for simplicity, 5 times 10, that's 50. So the force of gravity is 50 newtons. So this force of gravity is 50 newtons. So the normal force is going to be the same thing, remember? So normal force is the same 50 up in the opposite direction though. Okay? So we determine the force of gravity. Force is equal to the mass times acceleration due to gravity. We determine the normal force because the same magnitude in the opposite direction. And the force of friction, okay, again, force of friction. So the net force acting on this object, the net force acting on this object is because it's slowing down. It's moving to the right, but it's slowing down. So the net force is the force of friction. Remember, force of friction is equal to the coefficient of friction, that's a mu, don't worry too much, times the normal force. So they gave us the coefficient of friction, which is 0.1. So you plug that in your equation, and you're going to multiply by your normal force, which is 50. So that's a 0. So 0.1 times 50 is 5. So your force of friction, which is to the left, is 5 newtons. So we determine that the net force is the same as the force of friction, which is to the left, and then they ask us to determine the acceleration. Okay, so again, net force is equal to mass times acceleration. So the acceleration then is equal to the net force divided by mass. We said that because the object is slowing down, the net force is the force of friction to the left, and the force of friction is 5. Okay, divided by the mass, and we determined, well, they told us that the mass is 5 kilograms. So our acceleration is 1 meters per second squared. 1 meter per second squared. But again, remember that if the net force is to the left, the acceleration is going to be to the left. Okay? If so the acceleration is always in the same direction as the net force. this object moving to the right is slowing down because of friction. The net force is to the left, the acceleration is to the left. So if the object is moving to the right and the acceleration is moving to the left, that means it's slowing down. It's decelerating. It's decelerating. All right. So just, by just using Newton's second law, we can work out the motion of this object. All right. All right. Let's, so, all right. So we still have a few more problems to look at. Um, let's look at this one. All right. So, because if you understand what you're doing, then you can use your knowledge and work out these situations. So Eduardo applies a 4.25 Newton force rightward. Okay, so this is the applied force, 4.25 Newtons rightward to a object. It's a book, 0.765, to accelerate across a tabletop. The coefficient of friction between the book and the tabletop is 0.410. Determine the acceleration of the book. All right. So you're gonna use your so the first thing you have to do is draw your free body diagram. Okay. So we have an applied force of 4.25 to the right. Okay. The book weighs 0.765. You're going to slide it across the tabletop. The coefficient of friction between the tabletop and the book is 0.410, and they want you to determine the acceleration. So let's draw the free body diagram. All right, so let's do that. All right, so our book is right here. Okay, so the book is on a tabletop. So, okay, so the force of gravity on the book is downwards. Okay, and then you're going to have your normal force pushing up on the book like that. Okay, this your applied force to the right is 4.25. Okay, and then friction is going to act to the left. Your frictional force is going to be to the left. So force of friction. Okay, so this is your force due to gravity. And this is your normal force right up there. Okay, all right, so so the first thing you do is draw your free body diagram, and they gave you the coefficient of friction between the tabletop and the book, and you need to determine the acceleration of the surface. So you're gonna write out your equation. The net force is equal to mass times acceleration. Net force is equal to mass times acceleration. So to determine your acceleration, you need to get the net force and you need the mass. Okay? All right, so the net force, we have 4.25 Newton to the right, frictional force to the left. So we need to find the frictional force in order to determine the net force. Okay. So in order to get the frictional force, we know frictional force is equal to the coefficient of friction times the normal force. So we need to find the normal force. The normal force is equal to the force due to gravity. Okay? The force due to gravity is equal to the mass times the acceleration of gravity. So we have the mass of the book. So the force due to gravity, which is the same thing as the normal force, is equal to the mass of the book times acceleration due to gravity. All right, so for simplicity, we're going to use acceleration due to gravity as 10. So it will be the mass of the book is 0.765. And then we're going to multiply that by 10, acceleration due to gravity. So this would be, the force due to gravity would be 7.65. 7.65. So there's a point right here, 7.65. Okay? So your normal force is going to be the same thing as the force due to gravity. So this is going to be 7.65. Okay? So your frictional force due to friction is equal to the coefficient of friction. In this scenario is 0.41 times the normal force. The normal force is 7.65. 65. Okay, so when we multiply, so let's do a multiplication. All right, so 0.41 times 7.65 is equal to 3.14. So that's equal to 3.14. Okay, so there's a point right there. So the frictional force is 3.14 to the left. So the net force is 4.25 minus 3.14. So our net force, so force net, remember, there's the net force that's going to cause acceleration. The net force, okay, let's do the math here. So it is 4 minus 3.14, and that is equal to 1.1. So our net force is 1.1. Okay? Remember that your net force, this net force, is equal to the mass of the object, in this case the book, which is 0.765. 0.765 times acceleration. So if you're solving for acceleration, that's what the question asks. Determine the acceleration. So your acceleration is equal to the net force, which is 1.1, and you're going to divide that by the mass of the book. The mass of the book is 0.765. So 1.1 divided by 0.765, that is equal to 1.45. So the acceleration of the book is 1.45 meters per second squared. Okay? 1.45 meters per second squared. So you see, the first thing you have to do, you have to draw the free body diagram, outline all the forces and mass, and then you solve for the unknown. You have to use the fact that your normal force is going to equal to the force of gravity. You have to draw your applied force, look at where your friction is, and then solve. So let's do one more problem. All right. All right, so let's do this problem. All right, so in a physics lab, Kate and Rob use a hanging mass in a pulley system to exert a 2.45 Newton of force rightward on a 0.5 kilogram cart to accelerate it across a low friction surface or a low friction track. If the total resistance force to the motion of the cart is 0.72 newtons, then what is the cart's acceleration? So again, the first thing you have to do is draw the forces acting on the object. So you have a mass. So let's look at so you have a mass. Okay, you have a pulley system. Okay, that exerts a 2.45 Newton rightward force. So the applied force to the right is 2.45. Okay, so the mass the mass of the cart is 0.5 kilogram, and it's going to accelerate it across a low friction surface. Okay, if the total resistance force of to the motion of the cart is so the resistance is to the left. Okay, the resistance is to the left, and that is 0.72. Okay, to the left. We know the force of gravity is always downward, so force of gravity the normal force is always opposite, and it's the same magnitude, so it's a normal force. So normal force. So you draw your free body diagram, so you can put in the unknown. Okay, so the mass of the cart is 0.5 kilograms. So we know that the force of gravity is the mass times acceleration due to gravity. If we assume that acceleration due to gravity is 10 meters per second squared, for simplicity, Then 10 times 0.5 is 5. So our force due to gravity is 5 newtons. Our normal force is going to be the same thing. So that's 5 newtons. All right. So we can determine the net force because these two forces balance, the force of gravity and normal force balance. So the net force would be 2 point, let's draw that. The net force to the right would be 2.45 minus 0.72, and that is equal to 1.73. So the net force to the right is, all right, so let's write that. So force net, and force net is going to cause the acceleration. Force net is equal to 1.73. So it is this net force to the right which is going to cause the acceleration. And it's 1.73. So the net force is equal to the mass of the cart, which is the mass of the cart times the acceleration that is achieved. And they want to know what's the acceleration of the cart. So the acceleration of the cart is equal to the net force divided by the mass. The net force, 1.73, divided by the mass, which is 0.5. So 1.73 divided by 0.5 is equal to 3.46. 3.46. So the acceleration of the cart is 3.46 meters per second square, and that's to the right. Remember, meters per second squared. Remember that the acceleration is going to be in the same direction as the net force. The net force is to the right, so therefore the acceleration is going to be to the right, and it's going to be 3.46 meters per second squared. All right, so it's important for you well, the first step is to draw the free body diagram, and then you put in the known, and then you use your knowledge of Newton's second law to solve for the unknown. So we're going to stop here, and what we will do is
Okay.
next session we will